It's my pleasure now to welcome Dr. Tancredi Botto, co-founder and CEO at Muon Vision. So Muon Vision uses cosmic ray muon tomography to non-invasively X-ray mining assets, enabling real-time surface fluid and density monitoring for safer and more efficient mineral discovery.
Here we are. Thank you, Trisha, and thank you, Eduardo, and hello, everyone. My name is Tancredi Botto. I'm the CEO and co-founder of Muon Vision. Previously, I was an MIT scientist, and I've also worked in oil and gas exploration for 15 years. Mining metals is key to our future, yet the industry is squeezed between massive increased demand and chronically low ore grades. That means that much more earth needs to be moved, mined, and much more energy and water consumed to process the same 1 ton of copper. Muon Vision wants to break this cycle. Our mission is to boost efficiency, safety, and sustainability of critical minerals processing while supporting the industry transformation towards digital operations. I will pick as an example the heap leaching process, which today is a $100 billion industry and accounts for 20% of worldwide copper and other metals. Heap leaching is the preferred solution for low-grade ores that are expected to soon be a primary source of new copper. In heap leaching, mine ore is crushed and then stacked into huge piles, which are then irrigated with an acid-containing solution that ideally distributes uniformly, dissolving the metal contained in the mineral grains and being collected at the bottom. In practice, there are many reasons why moisture across the leaching asset is not uniform. This leads to 2 problems. Volumes with too little fluid will produce less metal, and volumes where too much fluid is accumulating may trigger potentially catastrophic landslide. So the question is ultimately how much moisture and where is it you have inside a leaching heap? But how can you quantitatively and accurately measure that? This is an important question, I believe, for any implementation of any AI or machine learning solution, as we heard from Brian before. After all, most sensors still provide point-like information, which in this case will be completely insufficient. And even the most advanced X-ray or geophysical probes only measure across a few inches at best. So what is our solution to this problem?
In the last few decades, scientists have finally been able to look inside ancient pyramids and volcanoes. Muon Vision is now using that same technology to revolutionize mining. The breakthrough behind this revolution? Muon radiographic imaging, also known as murography. Muons are subatomic particles naturally formed when radiation from distant supernova explosions collide with the Earth's atmosphere. Muons constantly penetrate every square meter on the surface of the Earth. At Muon Vision, we've developed a subterranean technology capable of detecting and recording muons as they travel deep underground. We then use that data to create 3D density maps of large above-ground structures like tailings dams and leach piles. In a mineral leach pile, for example, Muon Vision's technology can identify dry, low-density areas where leaching fluid isn't reaching. When operators can see this issue, they have the chance to adjust their processing and prevent hundreds of millions of dollars in assets from being left behind. In tailings dams, the same technology can also precisely determine the static vertical stresses on the material, as well as phreatic levels, thus validating the dam design and helping increase its performance. When you see deeper, you can work smarter. Muon detection empowers you to look inside mining's largest structures and optimize for efficiency, profitability, and safety. See deeper with Muon Vision.
Okay, thank you. So our solution is ultimately a nuclear imaging detector, and is analogous to take a diagnostic X-ray over an unprecedented large distance scale. This allows us to scan inside these high-value assets in order to identify, locate, and quantify underperforming volumes or regions. And with that information, we can then recommend practical and already available remedial strategies. After all, you can't manage what you don't measure. Our diagnostic surveys can generate value in numerous ways in leaching operations, primarily by significantly boosting metal recovery via optimized digital operations, as well as identify secondary leaching opportunities. Equally important, more precise leaching is also less costly and can optimize scarce water budget. Finally, our service helps manage multi-catastrophic slope stability and reduce the risk of unnecessary personal exposure. I want to conclude by showing you an example of our technology at work. So think of a leaching heap in its initial state as a dry sponge, and our density measurement as a balance scale that is inserted under the heap. Now add fluid. Now this displays the air and increases the bulk density of the material, something we do measure accurately by observing the corresponding decrease in the muon flux during this transient phase. But now look at what happens after the first 100 hours. Although the irrigation rate is the same, the heap has now lost weight and settled into an equilibrium where you have considerably less moisture than planned. Why? Well, a simple explanation: because the high irrigation rate has caused preferential flow channels. In other words, the fluid escapes more quickly and less metal will be produced. This is a well-known and hard to predict problem, and something you simply cannot look by just looking at the heap from the outside. To conclude, we have developed new applications for muon radiography, a well-known niche technologies. This has allowed us to build a unique patent moat around its many high-value potential applications. We are seeking collaborations and partnerships across industries to advance high-value use cases and commercialize our solutions to long intractable problems. Thank you.
Excellent. Thank you so much. We do have a few questions and a minute or two for you to elicit your response. So you mentioned tailing dams. Can you briefly illustrate how your technology adds value in this case?
Yes, I think I'm still sharing. Essentially, the value that we will bring, tailing dams, first of all, it's a well-known issue in the mineral processing industry, and has left horrible legacies around the world. How we bring value? Well, consider what is the state of the art today for analyzing tailing dams. In the best case scenario, low-cost technologies like taking a sample, which typically is not deep enough, are used, and the next sample may be several hundred meters away. And this is very hard to understand what's going to happen to something which is large dimension by definition. So the value we bring is to validate these asset models, measuring key properties like stress, as well as moisture content, as well as density non-uniformities, which are not expected to be there in the first place. And of course, provide long-term monitoring.
Excellent. Thank you. And quickly, the last question: are there other applications for Muon radiograph outside what you have discussed today?
There are, we believe. Of course, Muon radiography is a passive technology, so it's difficult for us to accelerate it. Most applications fall in the mining space. We have built a patent portfolio on slope stability and leaching heaps, but there are classical applications like void detection and mineral exploration, which are accessible to everyone, as well as, we believe, novel applications in mining plants. Similar heavy industries are likely to have potential applications as well. Thank you.
Excellent. Well, thank you so much. It was such a pleasure, incredible presentation.